Okay. The bob of a pendulum has a mass of 0.25 kilograms. If this pendulum is 1 meter long, what is its frequency? So we are looking for F. We know our mass is equal to 0.25 kilograms, and our length is 1.0 meters. Well, we know that F is equal to 1 over T, and we can find out our T from a different formula. So our T formula, since this is a pendulum, we look at our pendulum formula as 2 pi times by square root of L over G. Now if you get confused about which one do I use for pendulum, and which one do I use for the spring, just remember with the spring, that one has K in it because that's the spring constant. The other one then is the pendulum. Okay, so think the length is the pendulum, the K is for spring. Okay, so now we can put this, pardon me, sorry?
What's the thing on the bottom of L?
G. Yeah. That just looks worse? Okay, very good. All right, so we're going to do this one first, and then we're going to do this one second, in terms of our calculations. Can I use red? Does the red, the smartboard? No?
It's fine.
I can use it. So, number one, T is equal to 2 pi square root of L over G, which, if we plug that in, is 2 pi square root of 1.0 meters divided by 9.81 meters per second squared. So plug that into your calculator. .006, etc., and we put it to seconds, because T is in seconds, and we have all our correct units. So now our second calculation is where we go F is equal to 1 over T. So 1 divided by 2.06, etc., seconds is equal to 0.4949. Why can't I do things today? 4984 hertz, right? Frequency is in hertz. So now to sig digs, F is equal to 0.50 hertz, which maybe, should we go back and write that in our notes? Frequency, this is measured in hertz, T is measured in seconds. Just so we remember that. Period is in seconds, frequency is in hertz. All right, let's do number 2. A horizontal spring has a 1.5 kilogram mass attached to one end, and at the other end it's secured to a wall. If a force of 25 newtons is used to compress the spring, 16.5 centimeters, what is the period? Okay, so there's a little bit more information on this one. So think, I'm just going to draw a picture. Here's my spring, it's horizontal, and there is a mass at the end of it. Okay, so there's my mass. So it's a horizontal spring with a mass. So and this is, I've identified, this is simple harmonic motion. So I'm going to use my simple harmonic motion formulas for my spring. I'm just going to write down everything we know first. M is equal to 1.50 kilograms. F is equal to 25.0 newtons. X is equal to 16.5 centimeters, which I need to convert into meters. So we divide by 100 or times by 10 to the power of negative 2. Our centimeters cross off, and we have X is equal to 0.165 meters. And then what are we looking for? we are looking for period, so T is equal to question mark. So let's make kind of a roadmap of how we're going to calculate this. Well, we know our T formula for our spring is T is equal to 2 pi times by the square root of m over k. Well, for my spring lessons and things like that, I can find out k by using my F is equal to kx formula. Okay, so this is the first calculation I'm going to make, and then this is the second calculation I'm going to make. Sometimes that's nice if you just kind of set up a roadmap for how you're going to approach the question when there's those multiple steps involved. So number 1 is where we go F is equal to kx, and we rearrange for k. So k is equal to F over x, which is equal to 25 newtons divided by 0.165 meters. So k then is equal to 151.51 Newton meters. So now my second formula is to plug that into T. T is equal to 2 pi times by the square root of m over k. So now I can put these values in. Go 2 pi times by 1.5 kilograms divided by my k, which I just found. 151.51 Newton meters. Am I going too fast? No? Too slow? So then T is 0.62516 seconds. So into sig dig 0.625 seconds.